All right, welcome to today's topic. I'm Czech from SIT and I will be your voice today for this video. All right, firstly, I must apologize for the grainy video because as you can see, this is shot like in the wee hours, but I promise I will shut down this video screen in a minute. All right. So, software engineering is the topic that we are going to cover for the rest of this module. And the first thing that we want to do is to think about why we want to learn about software or why we need to learn about software engineering. Why does every university teach software engineering, in fact, for computer science or computing related subjects? And why did software engineering even become a full degree like the one in you are studying or some of you are studying right now in SIT? Okay, so these are the questions that we'll attempt to answer in this video. And part of the answers can actually be found in the nice set of pictures that you see over here, which are properly stolen from Professor Kareen, of course, who used to teach this subject. Okay, so you may want to pause the video to look at some of these pictures over here carefully. But in any case, the rest of this video would attempt to provide the rest of the answers to pretty much the motivation or why software engineering has become a field as big as you see right now. Okay, so now let me just remove this video because you don't really need to see my face. I just need to hear my voice. All right, so let me just do it right now. Okay, so why has software engineering become such an important field? Of course, in recent times, we know that software engineering is in high demand, whether it's in Singapore or the States, where we can see news of SE or software engineering jobs listed in the top rankings in terms of remuneration, as well as programming jobs hitting all-time high in the US, for example. Okay, but if we want to trace the origins of why it has become of such status, we need to go all the way back to the 1960s. Okay, so in this period of the 1960s, we saw a number of firsts, including the first Boeing 747, which was basically first revealed to the world, and it being still a staple passenger aircraft until today, as well as the first spacecraft. Okay, this is the first manned spacecraft. Um, as you can see in the diagram, this is Apollo 8. Okay, which pretty much paved the way for Apollo 11, which was the spacecraft that landed humans on the moon. But this was the spacecraft to leave Earth's orbit and to go into or to orbit around the moon. All right. So more related to our topic is this first. Okay, this is the first what is known as. I'll just change back to black. The NATO Software Engineering Conference. Okay, so why is this conference important is because this was when the term software crisis was being coined. All right, and why coin this word is because people have found up to this era, there was huge number of problems in software, in the creation of software, or basically, the outcomes of software that was created in this era. So it's basically, this blanket term that consolidated all the common problems they saw until then. Okay, problems like uh, busting budget. Okay, that means it costed much more than what was originally planned for, exceeding timelines, exceeding the originally planned schedules. Um, Other things are like bad code, okay, spaghetti code, unmanageable code, inefficient code were all typical qualities of what they saw in software until then. as well as uh, things, or rather software that did not meet the original requirements, or basically met only a small percentage of requirements. And lastly, the most severe thing is that, you know, the product, sorry for my handwriting, was never delivered. Okay, and then in 1972, a famous computer scientist received the what is known as the Turing Award. Okay, and this award basically is like the Nobel Prize of computing. Okay, it is basically given to people who has the highest, most significant contributions to science. In this case, computer science. All right. So this is called the Turing Award. And in his Turing Award lecture, he actually reiterated the software crisis issue or problem, or basically phenomenon, and which tells us basically how important the software crisis is. Okay, so what he did here was, um, to reinforce the importance of software engineering needing to become an important field of practice. All right. So by the way, this guy, which you guys should know by now, is Dijkstra. All right, and let me just hope that I spell his name correctly. And most famously known for Dijkstra's algorithm, which is the shortest path, all source shortest paths algorithm, amongst other things that he contributed to, operating systems, compilers, and networks. Okay, so this tells us, how important this software crisis problem was. All right, but all these anecdotal presentations, observational things, are somewhat not that convincing until this Standish group published the Chaos Report, which surveyed a lot of different projects, okay, 8,000 to be exact, or rather not exact, but around 8,000 projects were surveyed in this chaos report, which basically, shed a lot of light into what was happening with evidence. Okay, so here in this pie chart over here, we basically see three types of project or outcomes of project. Type 1 refers to successful projects. Okay, so this is success. Type 2 refers to projects that they call challenged. Okay, so this means that projects that were not completely successful, they would had issues with meeting all the features, or issues with other aspects of the managing the project or budget and so on. Okay, and thirdly, this type 3 are projects that completely fail. All right, and very quickly you can see that the number of successful projects are basically in the minority, and most projects basically fail, or are met with problems here. Okay, and if we take a closer look at some of these tables over here, which I've extracted from the original report, that's why it looks pretty dated kind of format. Um, on average, in terms of expenditure, okay, 189% more was spent than what was originally budgeted in these projects. And on average, in terms of time, it took more than 22% more time than what was estimated originally. And in terms of requirements, basically only, on average, completed about 61% across all the 8,000 or so projects that were surveyed. So you can see that all these are pretty big uh, percentages, and shows us, the scale of the problem. So out of all these companies, we can also zoom into one famous case study, which is the Californian DMV system. DMV basically stands for what is that? It stands for Department of Motor Vehicles in California. All right, so this system was basically set out to register all cars and drivers into this government, or rather this state system. Okay, so the agreed plan was to develop the system with $28 million, which is a huge amount, especially back then, in 5 years, which is also a long time. But the actual amount that was spent was actually way bigger than that, almost double. So the actual amount spent was 50 million, and it took 7 years. And the worst part of it is that it was, after 7 years, cancelled because even the product that was churned out after 7 years didn't meet the minimum requirements of the system. All right, so that's pretty sad. So, but the sadder part is this, that they set out to correct things in more recent times, 2006. All right, they set out to do it one more time in the sequel, okay, the DMV system part 2, okay, but as you can see in this news, it was also eventually cancelled. Okay, this eventually cancelled and spent like a whopping $208 million, half finished, with cancelled because of this reason, which is quite baffling. Little progress was being made in yet another 7 years. Okay, so this brings us to what we want to motivate in this video, uh, well, which was what we've set out to do, okay? Which is basically SE is important, okay? Very important for that fact. Um, and which brings IEEE to define SE of software engineering as the application of a systematic, disciplined, quantifiable approach to the development, operation, and maintenance of software. Okay, so this basically means that, sorry, I'm using too many basically that I'm annoying myself over here, but anyway, I'll try to avoid that. What I was trying to say is that um, this means that we need a proper understanding and application of software engineering, and this is of utmost importance in developing software, which is why this definition was carefully crafted out. And this definition, if we look at it a bit more carefully, basically means that we need to have a methodical approach to doing software, okay, which means that we need to do it step by step, and we need to be disciplined. In other words, have rules, or use a rule-based approach to doing it. And also, the outcomes should be quantifiable so that we know exactly what it means, by completing a certain feature. Okay? And here, the text in blue also tells us that, it's not just about writing code. Okay? It is more than just, a development phase. It's also about the operation and the maintenance of software. Okay, and if we move closer to today's era, okay, 2005, 2015, okay, the Standish Group continues to publish stuff year after year to highlight to people, what is the state of software engineering, or what is the state of software currently, okay, as further motivation for software engineering as a field. Okay, so if we look at the state across more recent years, it seems like there has been some improvements, over a long time ago, but um, basically, the improvement is very slow or almost stagnant across these 5 years that we see over here, which also means that software engineering is still, a field that is yet to be fully established or solved. All right, and in this 2015 report, they also showed us something else, which is basically, sorry, I use basically again. Uh, the larger the size of the project, um, the chance of success would be greatly reduced, whereas in the opposing end, it would the chance of having challenged or failed projects would be much higher. And which also means that the larger the size of your project, okay, that more software engineering needs to be involved, or more correctly, the importance of software engineering becomes higher when you have larger size projects. You need more dedicated application of good software engineering practices. Okay, so finally we reached the end of this video, and I would just like to leave you with this picture that is closer to our hearts in recent years.